Hello everyone, welcome to the video. We're looking at section 4.3 where we're going to be dividing polynomials. So we want to know how you can use the factors of a cubic polynomial to solve a division problem involving polynomials. We have two different ways of approaching these uh, these types of questions. Uh, One way works for every scenario, and another form works only when it has the specific parameters in that particular problem, and I'll show you what that actually is. So the first thing we're going to look at is the one that you can use for every scenario. All right, and it involves using long division. All right, and we've been doing long division since elementary school, and we can you can take. So basically, you're doing is you take if you have a fraction like I don't know like 3,128, and you're dividing it by let's say 7, which means that top number, the 3,128 goes on the inside of the division, and then the 7 goes on the outside. You look at the 7, can it goes into 3? No, it can't. So then we go into 31. How many times does 7 go into 31? The answer is 4, which means you take and you put 4 times 7, which is 28. What we do from there is we subtract it. So now we take 31 minus 28, and you get 3. And then you drop down the 2, so now you have 32. How many times does 7 go into 32? That's still 4. So now we got 28 again. 32 minus 28 is 4. So now I got 4 and 8. So that gives me 48. So how many times does 4, or how many times does 7 go into 48? The answer is 6, because 7 times 6 is 42. And when you subtract it, it is going to give you, what, 6? And usually you would use it as as a remainder of 6, but what you do is you can write it as a fraction, and then the remainder is 6, and then the denominator would be 7. So 3,128 divided by 7 is actually 446 and 6/7. So that's similar concept of what we're going to be um, looking at today. The other one is you can use synthetic division. So synthetic division is only used when you have a scenario where you're dividing by a, a 1-degree polynomial. That lead coefficient is 1, and and it's going to be subtracted by k. So, for example, you could have whatever, you know, value that you're going to be dividing by, but that has to be x minus or plus. You just be the opposite of some value. So you could say it's be like 5. So it'd be like x minus 5. So that means that when you do your synthetic division, the value here would be the opposite of that, and that would be 5. And I'll show you what that looks like as the examples allow us to use that type of type of division. So this one here, we have 2x to the fourth plus 3x to the third plus 5x minus 1, and it's going to be divided by x squared plus 3x plus 2. So there are a couple things that we have to keep in mind when we use long division, because it's being divided by a trinomial. We can't use synthetic division in that scenario. We only can use the long division route. So there are two things that have to happen before we get started. One is it has to be in standard form, both the dividend and divisor. Next thing we have to take into account is, are there any missing terms? So if you look here, x to the fourth, x to the third, x to the second, there's a missing term. So anytime you have a missing term, you're going to include it with a 0 as the coefficient. So essentially, like this one here, nothing's missing, 2, 1, constant. So this goes to the outside, and what goes on the inside is going to be the 2x to the fourth plus 3x to the third. Since there is no x squared, you're going to replace it as plus 0x squared plus 5x minus 1. So how you go about trying to solve these types of problems is kind of similar like what you did with the numerical values. What I have here is a 1, 2, 3 term polynomial that I'm dividing it by. So what I'm going to do is I'm going to find where that, so this is 1, 2, 3. So actually I'm going to start right here. So I'm going to start right here. Now I'm going to place a value right here, and essentially that value, when I multiply it by x squared, I want it to become 2x to the fourth. So what times it by x squared is going to give me 2x to the fourth? The answer is 2x squared, because 2x squared times it by x squared is 2x to the fourth, and you're just distributing that. So now you're going to take 2x squared and times it by 3x. Then that's going to give me plus 6x to the third. And then finally, 2x squared plus 2 is plus 4x squared. And if you notice, every value that I have above it is a like term. X to the fourth, x to the third, x to the second. I can combine that. Now, just like what you did with the numerical values, you're going to subtract that. So all you're going to do now is change the sign. This is minus, this is minus, this is minus. This should cancel. This becomes negative 3x to the third. This becomes minus 4x squared. And now we drop down here. This is my plus 5x. And now we go through the process again with the next value. Here, I'm just going to get rid of the circle. So this was 2x squared. And now the next value is whatever you place next, is when you multiply it by x squared again, it's going to get, I want it to be negative 3x to the third. Well, it's going to be minus 3x, because negative 3x times by x squared is going to give me the minus 3x. I get the same value. Now I take the negative 3x and times it by the positive 3x, so that's going to give me negative 9x squared. And negative 3x times by 2 is negative 6x. And again, you should notice that where you have like terms. Now, again, you change the sign. So now this becomes positive, this becomes positive, and this becomes positive. This should cancel. This turns into 5x squared, and this turns into plus 11x, and then I drop down the minus 1. So to finish up, now I got to place a value, multiply it by x squared, is going to give me 5x squared. Well, that's going to be plus 5. So 5 times x squared is 5x squared. 5 times 3x is plus 15x. And 5 times 2 is plus 10. So now, from here, we are going to looks like subtract. So this becomes negative, this becomes negative, and this becomes negative. This gets canceled. This turns into a negative 4x, and then this turns into a minus 11. Okay, there's nothing left that I can drop down, so negative 4x minus 11 is my remainder. But how we are going to write this is our answer is going to be 2x squared minus 3x plus 5 plus the remainder, which is negative 4x minus 11 divided by my divisor, which is x squared plus 3x plus 2. And this is my result. All right, so again, looking at long division, let's look at, we'll do part 1. Part 2 is very similar to the one we just did. I encourage you to work on that, but if you're not sure, please comment down below. So x minus 1 goes to the outside. On the inside, 3, 2, 1 constant. There are no missing terms, so I can just write it as is. Since it's a binomial, I'm going to start with the second term, which is right here. So now, what value am I going to place there? Times by x is going to give me x to the third. My answer is x squared. X squared times x is x to the third. X squared times negative 1 is negative x squared. Change the signs. This becomes minus, this becomes plus. This should cancel, which it does. And in this case here, this one cancels as well. So now I'm left with, what, negative 2? So I'm just going to write this as 0x squared. So with that, this one here is going to be, what, plus 0x? So then 0x, so this becomes 0x squared. This becomes negative 0x. Change sign. This will cancel. This still now becomes negative 2x. Drop down plus 8. And from here, I can take minus 2. So negative 2 times by x is negative 2x. Negative 2, so that becomes positive 3. Plus minus cancels. This turns to 5. So essentially, our answer is going to be x squared. I'm just going to put it as minus 2 plus 5 divided by x minus 1. my bad. This one here, this is not 3, this is 2, which would make this 6. So then that remainder would be 6. I was wondering why that didn't look right. My apologies. Even the best of us make errors. All right, so from here, they want us to use synthetic division in order to solve it. You're going to find that this is a much easier approach. And in fact, what I'm going to do is I'm going to show you both the long division way and the synthetic division way to show you that it's the same thing. So we're just going to do number 3. And we'll do long division first because that's what we're familiar with, and then we'll use synthetic division after that. So x minus 2 on the outside, this is going to be x to the third minus 3x squared minus 7x plus 6. 3, 2, 1, constant. Nothing's missing, so we don't have to do that. So second here, this is going to be just x squared, because x squared times x is x to the third, x squared times, so that's going to be minus 2x squared minus plus cancels. This turns into negative x squared minus 7x. We're going to drop that down. So now this is going to be a minus x, because negative x times x is negative x squared. Negative x times 2 is going to be plus 2x. Change the sign, change the sign. This gets canceled. This turns into negative 9x, and then I get the plus 6 from the top. Finally, this is going to be what? Minus 9. And so I get negative 9x, and I get plus 18. Change the sign, drop this down. 6 plus 18 is what, 24? So remember, remainder is 24. So I'm going to have this as plus 24 over x minus 2. Man, I'll tell you what this is. So actually what it should be is this should be positive 18. This is minus, so this turns into negative 6. So this answer here is negative 6 over x minus 2. 12. Negative 12. I'm just batting 1,000 here. My apologies. X squared minus x minus 9 plus negative 12 divided by x minus 2. My apologies. So to use the synthetic division way, what you're going to do is you have this x minus 2, which means that you're going to, like you did in the previous, like we did, I talked about in the previous ones when we evaluated, you were going to write this as the opposite of your constant value. So if it was a minus 2 in that it's being divided by, it's going to be a positive 2 here. So if this was x plus 2, it would be a negative 2 where we start the synthetic division. Then all you're going to do is look at the coefficients of what our numerator is going to be. So it's going to be X to the third is 1. X squared is negative 3. X to the first is negative 7. My constant value is 6. Drop down the 1, times that by 2 is 2. Add them together, I get negative 1. Multiply negative 1 and 2, I get negative 2. Add them together, I get negative 9. Times that by times negative 9 and 2, I get negative 18. And from here, I get negative 12. So what these numbers are and how they incorporate with the answer that we just got, this negative 12 is your remainder. Negative 9 is your constant value. Negative 1 is x to the first. The positive 1 is x to the second. If you add any more, it'd be x to the third, x to the fourth, and so on and so forth. So now it's going to be x squared minus x minus 9 plus negative 12 over x minus 2. I get the same answer. And I would have realized that what I did in the long division at the end was incorrect because it would have been different than what it was from the synthetic division. All right, I do find this to be easier, and it's nice when it fits the parameters for the problem. So now here it says use synthetic division to evaluate 5x to the third minus x squared plus 13x plus 29 when x equals 4. So when they tell you that they don't have anything that's division by, and they're giving you an x equals something, that is the number that you use. So negative 4 would then just get placed to the outside. 3, 2, 1 constant, there's nothing missing, so it's going to be 5, negative 1, 13, and 29. Drop down the 5, times that by negative 4, which is negative 20. Add them together, negative 21. Negative 21 times by negative 4 is 84. Add those together, we get, what, 97? Times that by negative 4, I get negative 388. And what, add those together, I get negative 359. So now that there's nothing left, your answer is, oh, they just want you to evaluate. So your answer is 359. So that's what you looked at in the previous section when we either said use direct substitution or synthetic division. And then these values are very similar to that first example. Again, I encourage you to do so, work on those problems. If you have questions, please comment down below, and I will be more than happy to answer your questions. I do apologize for some of the mistakes in the video. I was able to at least go back and change them. That's just how it goes sometimes. I hope this helps. Until next time.